Back to my car problem. The average miles per gallon was 27 with standard deviation of 5. This was found from a sample of 64 cars. What's the probability that the average is greater than 28? The average miles per gallon was 27 with a standard deviation of 5. This was found from a sample of 64 cars. What's the probability that the average is greater than 28? Okay? So what's different about this problem than the last problem?
Working with averages.
Right, we're asking the probability that the mean or the average is greater than a value, rather than the probability a random car has a value greater than something. Okay? Previous problems were what's the problem? The next car driving in the lot has a certain miles per gallon. This is what's the probability the average of 64 cars has an average miles per gallon greater than 28. And the average of the averages is what? The population mean. Okay? So, here is my average, 27. Here's 28, the value I'm interested in. So this is the area that I want to find. So I have to convert to z-scores. Okay? I have to be careful. I have to convert that standard deviation of the average. How do I find that? That's the standard deviation divided by the square root of n, which in this case is 5 divided by the square root of 64. That's 5 divided by 8. And that is 0.625. Is that right? 5/8 is 0.625. Okay? So now I have to find the z-score for 28. Now notice how I write that z-score down. I'm always careful. That z-score is for an average of 28. This simply equals 28 minus 27 divided by the standard deviation of the average, which I just found to be 0.625. So this is 28 minus 27 divided by 0.625, and that is 1.1 divided by 0.625, and I think that is 1.6. Is that right? Someone check me. Is that right? I'll have my son watch this tape. He doesn't believe I can figure these out. I'll be careful not to watch them when I start making mistakes. Here we go. So to find this is normal. CDF 1.6, comma 10. So what is normal CDF 1.6, comma 10? We don't even need to look that up, do we? 1.645 is 5%. So this must be just a slightly bit more than 5%. What is it?
0.054.
0.054. So the probability that the mean is greater than 28 is 5.4%. Now, just for funsies, let's say that we went out and we sampled 64 cars. again in the next month. And we found the average miles per gallon to be 45. What would you think?
Where'd you get those cars from?
Yeah, what did you say?
Where'd you get those cars from?
Well, one of two things had to happen, right? Number one, our sample's unrepresentative, or number two, what? The sample, the mean is no longer 27, because the odds of getting a sample of 45, given the standard deviation of an average is 0.625, that would be how far away? 45 from 27 is 18 marks divided by 0.625. We'd be 20, 25 standard deviations out. That just can't happen. That's just not going to happen. So one of two things have to occur. Either one would be fine. Number one, the sample's unrepresentative, or number two, that mean has changed. Okay, does that make sense to everyone? Either the mean has changed or the sample is unrepresentative. So when we're doing election returns, and all of a sudden you think that John McCain's winning somewhere, and for the last 20 days Obama's been winning, so one of two things had to occur. You either asked the wrong people or it's changed. So what do you do? So if you're on the election committee, what do? You can't change your sample. So now you're going to really look at those demographics and see if the demographics of your sample match what you believe the population to be. And that's one of the things that really happened with the Obama campaign, because like in Athens County, Ohio, that went for Obama, and I don't think it's ever gone Democratic. It went very strongly because of the student population down there. So that's what they started looking at, those demographics, and then they knew things were changing on them. Okay? Everyone okay with that? All right, new